Dear student, now we are going to start today the new topic, that is strength of organic acids and bases. The strength of organic acids and bases is important as the basic behind it. You also learn in 12th standard also Arrhenius theory of acid, Lawrence Brown's concept of the acids and bases, etc. Now here we are going to study the important reasons which may ask on this chapter. If I am going to take the important reasons for this, the first one we are going to see, before going to start this topic, some basic ideas are there. It must get clear. Now here the strong acid having the low pK value, but pKb value will be more. pK value will be less if an acid is a strong acid, and if it is a strong base, its pKb value will be low. Therefore you have to remember that if the acid is strong, then its pKa value will be less, and if the base is strong, its pKb value will be less. Now the important reason is the formic acid. Why the formic acid is stronger than the acetic acid? Now here you can see the pK value also. See, the pK value is 3.77 and here pK value is 4.76. According to this, if low pK value, that will be the strong acid. Therefore in this pK value, low is of formic acid. Therefore this acid will be the strong acid, while acetic acid pK value will be more. Therefore it is a weak acid. Okay, but why formic acid is stronger and acetic acid is a weaker acid? In this case, this is a formic acid. H, as you know, HCOH is a formic acid. The dissociation takes place. It gives a proton minus H positive will get removed, and then the anion will get formed, that is called as a formate anion. This is its conjugate base, which is represented Cb. Cb means its conjugate base. By removal of H positive, the anion form is called as formate ion, which is its conjugate base. This conjugate base gets stabilized because this negative charge will feed back and negative charge will be here on oxygen. Therefore this negative charge gets stabilized. That means the anion gets stabilized. In acetic acid, the OH bond, weak bond, therefore in this case the bond breaks, it gives acetate ion and then it gives this. The acetate ion negative charge gets means whenever it feed back. But what is the basic difference in formic and acetic acid? In formic acid there is a hydrogen and in acetic acid there is a methyl group. As you know, the methyl group is an electron donating group which shows the plus I inductive effect. In case of acetic acid, the CH3 group shows the plus I effect, plus I electron donating inductive effect. Due to this plus I effect, the polarity of the OH bond decreases. Therefore in this, the polarity of the OH bond will decreases due to plus I effect of the methyl group. Then it, by removal of H positive, it forms the acetate ion. This acetate ion is its conjugate base of the acetic acid. That does not get stabilized. This is anion. This acetate anion does not get stabilized because the methyl group is an electron donating group. Here it will donate. Actually negative charge should get stabilized. If it doesn't get stabilized here because methyl group is there and which shows plus I effect. Due to this plus I effect, this conjugate base doesn't get stabilized. While in case of formic acid, instead of methyl group there is a hydrogen. Therefore plus I effect is absent. Therefore in formic acid the plus I effect is absent. By removal of H positive, the formate ion will get formed and this formate ion will get stabilized because there is no plus I effect. Plus I effect is absent in case of formic acid, and therefore this conjugate base gets stabilized, and due to this the formic acid is more stronger than the acetic acid. Now, some important things in this chapter. If electron withdrawing group is there, it shows always the minus I effect. It stabilizes the anion and acidity will increase. Therefore, you have to remember, if minus I effect is there, any electron withdrawing group is there like chloro, cyano, NO2, COH, then such group shows minus I effect. Due to that minus I effect, the conjugate base gets stabilized, and due to that the acidity will increases. Exactly opposite to this, if electron donating groups are there, then it shows the plus I effect. Due to plus I effect, it does not stabilize the anion, means it does not stabilize the conjugate base, and due to that acidity decreases. Then another important thing, if there is a sp2 carbon, means carbon contains a double bond is there, maybe in the ring, or maybe that sp2 carbon exerts always minus I inductive effect, electron withdrawing inductive effect. And if electron withdrawing inductive effect is there, acidity will always increases. If sp3 carbon is there, means single bonded carbon doesn't contain any double or triple bond, then in that case the sp3 carbon exert the plus I effect. If plus I effect is there, acidity will decrease. Therefore, minus I effect will increases the acidity, while plus I effect, electron donating effect, will decreases the acidity. These are some important basic things. Now we need in this, therefore we can say here methyl group. In this case, the again we will revise, formic acid is stronger than acetic acid, because in this case, whenever we are considering acetic acid, methyl group shows the plus I effect. Due to this plus I effect, the polarity of this OH bond will decreases. Then by removal of H positive, it forms the acetate ion. This acetate ion does not get stabilized due to the plus I effect of the methyl group. In formic acid, there is a hydrogen, it forms a conjugate base, doesn't contain any plus I effect. Therefore, this plus I effect is absent in formic acid, and due to that the conjugate base gets stabilized, and therefore formic acid is stronger than the acetic acid. The second reason is why the monochloroacetic acid is stronger than the acetic acid. Whenever we compare the acetic acid and whenever we compare the monochloroacetic acid, one of the hydrogen of acetic acid is replaced by the chlorine. As you know, the chlorine is an electron withdrawing in nature. It withdraws the electron. Therefore, chlorine is electron withdrawing in nature. Therefore, it shows minus I effect. That minus I effect stabilizes the negative charge on the anion, and therefore the delocalization means whenever H positive will go, it forms its conjugate base. That conjugate base gets stabilized due to the minus I effect of the chlorine. Therefore, it is a stronger acid, monochloroacetic acid. While in acetic acid, the same reason, the methyl group is a electron donating in nature. Therefore, whenever the anion will get formed, its conjugate base will get formed. That conjugate base does not stabilize due to the plus I effect of the methyl group, and therefore monochloroacetic acid is stronger than the acetic acid. Now, the another reason why the trichloroacetic acid is strong, whenever we compare with monochloro or acetic acid or whatever, the trichloroacetic acid is always a stronger acid, because here in trichloroacetic acid, monochloroacetic acid only one chlorine is there, but in trichloroacetic acid there are 3 chlorine group, means electron withdrawing effect will increase. Therefore, in trichloroacetic acid 3 chlorines are there. Therefore, the electron withdrawing number of electron withdrawing group increases. 3 chlorine are there, therefore electron withdrawing group increases. Due to that, minus I effect increases. As minus I effect increases, acidity increases. Therefore, in trichloroacetic acid, 3 chlorines are there. The chlorines are the electron withdrawing in nature.